Hello everyone, I'm Samuel Hawk, a doctoral candidate at electrical engineering here at NC State. I do my research in the NBC's lab under the supervision of Dr. Kranos Williams. The overall goal of my research is to help biologists to translate data into knowledge and develop computational methods for better understanding biological systems. I want to take this time to introduce you to one of the projects I am working on, which is the Sweetpotato analytics for produce provenance and scanning. The goal of this project is to help North Carolina farmers produce better quality sweet potato using machine learning and data analytics approaches. Sweet potato is the seventh most important crop in the world and one of the most important crops here in North Carolina. A major problem in sweet potato breeding is shape deformation. Sweet potato shape is highly variable and often the reason of great economic loss to farmers. As you see in this picture here, the US #1 sweet potatoes have very high market values, whereas the culled sweet potatoes are often discarded and do not end up in the retail stores. In this project, we are trying to identify different factors that determine sweet potato shape. Through data analytics, we can identify robust sweet potato cultivars and provide recommendation to farmers for better practices to produce US #1 sweet potatoes. This is a sweet potato field post-harvest, and you can see many sweet potatoes were not harvested as they had shape deformation. Through data analytics, our goal is to reduce this type of wastages and make sweet potato production more profitable and sustainable. One of the first steps of identifying the shape control mechanism in sweet potato is to be able to quantify the sweet potato shape. In order to do that, we worked with horticulture crop scientists working at the NCDA research stations and collected sweet potato image samples that were taken by this automated sorter. We used these images to create 3D models of sweet potato and extracted different 3D shape features from this 3D model. We verified our estimated features with laboratory experiments, and these graphs show that our results were closely aligned with true experimental measurements. With the automated shape extraction approach, now we can look at shape features across thousands of sweet potatoes across different cultivars. And this type of analysis will help researchers, breeders, and farmers to identify sweet potatoes that have more robust shape features. At the same time, we have developed a machine learning pipeline which can detect if a sweet potato is US #1 or culled using the 3D shape features that we have extracted. We collected different datasets related to sweet potato agriculture. Using these aggregated datasets, we developed a decision support platform where we can use data analytics approaches to understand how different factors affect sweet potato shapes. With this aggregated database, now we have the ability to look into how factors like precipitation, temperature, and fertilizer affect sweet potato shape and provide valuable recommendation to the farmers.